Morning in France, good afternoon in Vietnam. I'm very happy to introduce this second sequence of GEM Vietnam webinar series based on our special COP26 report we released last November on day one of COP26. So this second sequence opens with a webinar on the updated climate scenarios for Vietnam. And we're very happy to have Associate Professor Ngo Duc Thanh from the University of Science and Technology, Hanoi. He's also a lead author of the IPCC report, the first working group of the latest IPCC report. Also presenting with Professor Thanh, Dr. Tran Anh Quan from Hanoi University of Mining and Geology. So you will be presenting for 30 minutes, basically the work you've done in the first chapter of our COP26 report and the ongoing work you're completing right now. And then we will have 30 minutes of discussion with Professor Phan Van Thanh from the University of Science, Vietnam National University, Hanoi, and Dr. Do Xuan Hong from Nong Lam University in Ho Chi Minh City. So thanks a lot for accepting this invitation to discuss this work. You will have basically 30 minutes to both of you discuss and the answers of Thanh and Quan. And after that, we will open the floor for a discussion from the general audience. Maybe I want also to say that this webinar is recorded and will be put online so that you're all aware that if you intervene, you will have your image on the IFD YouTube channel. This first session will be, after this first session, we'll have 5 other sessions each week from now on, each Wednesday. And I will tell more about that at the end of this webinar. So without further introduction, I give the floor to Thanh for the first presentation. Thanh, the floor is yours.
Thank you very much, Etienne. Hello, everyone. So I will share my screen first. Can you see my screen? Okay. So it's my great honors to be here today and to introduce with you, as Etienne mentioned, about the first part of the GEM's COP26 report. And what we have done in the first part, the first chapter, is we discuss about the main issues of climate change in Vietnam and the methodology we adopted within the GEM's project to build climate projections for Vietnam. So the first part, I will summarize a little bit the chapter 1, and then the second talk by Quan, he will introduce about the methodology, the dynamic downscaling method he applied for building future climate scenarios for Vietnam. The context of this study is, we all know that Vietnam is severely impacted by climate change. And within MONRE has already published several, a series of reports on climate change and sea level rise scenarios in 2009, 2012, 2016, and recently 2021. That means last December. And next part is the Paris Agreement. And the Paris Agreement, with the agreement, try to limit global warming to well below 2 degrees Celsius, and we will try to limit, even below 1.5 degrees Celsius at the end of the 21st century. So the question from MONRE or from the Department of Climate Change to GEMS is whether we can identify the magnitude of climate change in each region via different global warming levels in Vietnam or not. And our chapters also, try to address this question. So in order to do that, first we we assess the past climate change in Vietnam by collecting the information, the data from 150 stations for the period of 1981 and 2018. The difference with the national report of climate change issued by Monre is by Monre, the data period is from 1958, but the number of stations, with much less number of stations, because the coverage of the data period is not the same for all stations. So here we could collect the information homogeneously for 150 stations, and then based on that, based on the daily data we collected, we could analyze the different variables, climate variables, as well as extreme variables index here. So within the report, we only highlight the trend of the 10 variables as shown in this table. However, we, based on the data collected, we can compute much more papers in variables, as we wish. So here I would like to highlight some quick results of our past trend assessment. And you can see that here is the trend of temperature over the 150 stations Vietnam. So mainly we can see that temperature increase in the past 40 years with the average rate of about 0.2 degrees Celsius per decade. Okay, and the rate of temperature increase had been faster in recent decades compared to to earlier time in the time series. And then if we compare the maximum daily maximum and daily minimum temperature, we can see that the average increase is difference between maximum and minimum temperature, and we can see that minimum temperature seems to increase higher than that of maximum temperature in Vietnam, and that means the diurnal temperature range, the differences between maximum and minimum within a day, decrease, and this reduction in range can also affect, impact the different aspect of life, such as human health or agriculture. And then also we compute other variables like a number of hot days, number of cold days, and as expected, you can see that number of hot days seems to increase over Vietnam. Number of cold days decrease, and number of cold days only concentrate in the northern part of Vietnam due to the geographic location of the stations. Okay, so in the southern part we only have the warm regions, and that's why we don't have cold days in the southern part of Vietnam. For rainfall, the trend also shows the different behaviors over the different stations of Vietnam. So some stations you can see decreasing trend, some stations you can see increasing trend, and the seasonal trends also show that rainfall has the highest increase in autumn. Okay, and average for all the regions of Vietnam, we can see a slight increasing trend of about 5.5% over the whole Vietnam. And then similarly, you can see that the maximum and of rainfall, annual maximum of 1 day rainfall, annual maximum 5-day consecutive rainfall vary differently among stations. Okay, some stations you have decreasing trend, some stations you have increasing trend. So that's what we've done so far for the past climate trend. And then the next part is we have built a new gridded data set for Vietnam on the 10-kilometer grid cell, and based on that observed grid data set, that we have built future climate change scenarios. Okay, and later on, Quan he will present about this, about the results of the downscaling technique we apply in this chapter. However, here I just would like to highlight some key points. The first one, for climate change scenarios, we all know that we need the input from greenhouse gases concentrations, And then global climate models were used. However, the resolutions of global climate models are normally not adequate for regional use. And then output from GCM, global climate models, will be downscaled to higher resolutions in order to obtain the regional climate projections. That's the theory. And in this report, we apply two-way downscaling technique. The first one is dynamical downscaling, and the second one is statistical downscaling. Okay. For dynamical downscaling, we apply the system currently used in IMHAN of Monterey with 14 experiments for temperature and 5 experiments only for rainfall for the two scenarios, 4.5 and 8.5. Okay. And the second downscaling technique is the BCSD, the bias correction and spatial aggregation method, the BCSD one that Quan will report later. And this method, we use 31 global climate models from 86 to the end of the 21st century for the different RCP scenarios. And the downscale data, the output of this part are freely available at the following link. And the size of the data we share is about 2 terabytes of storage. And later on, as I mentioned, when we discuss about that, and we can see the different levels of temperature increase globally on your left-hand side figures, and over Vietnam on your right-hand side figures. Okay, so we can see the differences between the dynamical downscaling technique and also the statistical downscaling technique here. And for temperature, we can see that the two techniques seems to be very good in good agreement with each other. And then the future increase, from that, the reasons we can see that in the future, temperature increase seems to be faster in the northern part of Vietnam. And the seasonal change, we can see that the highest change increase will be in summer. That means we will have hotter and hotter temperature over Vietnam. For rainfall, we can see that from dynamical downscaling, the 5 experiments seems to show an agreement of general increase of rainfall over the whole Vietnam. Okay. However, the BCSD downscaling show more uncertainties. And then one important point of this report is we try to assess the trend of climate in Vietnam with the different global warming levels, 1.5, 2, 3, and 4 degrees Celsius. So this means globally, if temperature increase about 4 degrees Celsius compared to the pre-industrial period. So the question is how much temperature will increase in Vietnam, okay? So from the two dynamical downscaling products, we can see that, for example, for 4 degrees Celsius increase, the temperature over Vietnam can also increase about, a little bit less compared to the global warming levels, okay? And if temperature, global warming levels increase about 1.5 degrees Celsius, so the temperature over Vietnam compared to the reference period 86-2005 is about 0.7, 0.9. So if we add up also the difference between 86 to 2005 to the pre-industrial period, so we will arrive to about 1.3 degrees Celsius, which is reasonable because Vietnam is located in the tropical regions. So the global temperature increase faster compared to the temperature of increase over tropical areas. And as similarly for rainfall, we also can see the uncertainties of future projections with a different output we have. Then here I will not spend more time on this. Some conclusion we can obtain from the first part, the first chapter we have, is that whenever you consider the future climate scenarios from the different downscaling technique, So we need to very carefully take into account the uncertainties, of the report. Also, now what we've done within this chapter is we use the CMIP 5 and we downscale CMIP 5 data, and now CMIP 6 data is available. So we are also we need to update the information of CMIP 6, and Quan will also talk about that later. Okay, and another point is the probabilistic method should be also taken into account, because we know that in the future, in order to take into account the extreme risk, okay, so we need to quantify the tail of the probability distribution, that we may don't have the full picture if we use only the existing CMIP 5 GCM. So there's a method, probabilistic one, we can use to take into account this tail. And then the last point we would like to mention is the high resolution 10 kilometers BCSD climate scenarios for Vietnam can be downloaded and used free of charge. Okay. And within the project, we have built the dynamical map, in order to extract the information. I'm not sure if I'm sharing the map. So the map can be is interactive online. For example, you can see here the map of Vietnam. You have the different regions. Okay. So for example, you want to highlight the information, the change over the Northeast one. So you click there, you can select the models. You can select the scenarios you wish and the year, and then you submit, and you can obtain the images. Okay, the images. Okay. So we are also uploading the function of this website in order to give you the information of each province of Vietnam, not only at the 7 sub-regions, but for each province of Vietnam. Okay, so I go to the end of my presentation today, and I'm looking forward to discussing more with you in the Q&A session, and with the discussion of our two guest speaker today. So next, I would like to invite Quan for your presentation. Thank you.
Hello everyone, I will share my screen. Hello everyone, can you see my screen?
Yeah, we can see it well.
Yes, very well.
I'm Quan from the Working Package 1 of GEMS, and my presentation today will be about the update on the climate scenarios for Vietnam. Today we will talk about several things. The first one is the reasons why we need high resolution climate data, and the method we use to increase the temporal and spatial resolution of climate data for the GEMS report, and the result of the method validations. And finally, will be some brief information about the future climate of Vietnam. And at first, why we need the downscaling method? As you know, the GCM model we use usually give us the climate projection at global scale with the resolution from several hundred kilometers. With GCM, we can know pretty well how the climate system in our planet works, the circulations, the climate zones. However, the GCMs are very coarse and their spatial projection is too smooth. And if you look at the images here, you can see between the low, the high resolution and reality, and the difference is significant with GCM and reality. And usually we need high resolution data for the research, for the regional research, and or for the local conditions. And to achieve that, we need downscaling method, which is a method to increase the resolution of climate data. And usually we have two kind of approach. The first one is dynamic downscaling, which is preferable by many researchers. It works by nesting a GCM model inside an HUMG model that provide higher resolutions. But you know that dynamic downscaling is physical consistent and generally give more accurate result, but it requires a lot of computer resource and time consuming. So there is an alternative method, we call it statistical downscaling, which based on the empirical relationship between historical climate conditions and the local climate conditions. This method assumes this kind of relationship will continue in the futures. This method is faster, flexible, but it also has many uncertainties. For building the climate scenarios of Vietnam, we use the statistical downscaling method that called the basis corrected spatial disaggregations, or the BCSD, which was originally invented by USTH in 2007, and it has been proven that the BCSD method is comparable to any state-of-the-art downscaling method so far when the conditions are met. And basically, the BCSD method includes two steps. The basis correction step, we call it BC, and the SD step, or the spatial disaggregation steps. With basis correction, we use the quantile mapping. Here it is a famous bias correct method in climatology and hydrology studies. With quantile mapping, we correct the simulated data by observations data where the value in simulated data would be replaced by the value of the same percentile in observation data set. With the figure you can see in here, we try to bias correct the model XS13, and finally we will have the basis corrected XS13 in red color, very close to the observation in the black color, which have been proven the effectiveness of the quantile mapping method. And then we come up with this, the second step, the BCSD, the spatial disaggregation step. In here, we spatially translate the basis corrected future model simulations from the cost scale to the target 5 scale through 3 smaller steps. The first, the filtered chain factor of temperature and precipitation are calculated for the coast resolution in here. Then the chain factor will be interpolated to high resolution of the same level with the observation data we have by the simple interpolation method. And finally, at the third step, we merge the chain factor with the observed climatology by randomly select a month from the observation and scale its daily data with chain factor. In this, with this approach, we can maintain the daily sequence, the diurnal sequence of the past climatology with the change in the future climate conditions. And it's all about some information about the BCSD approach. And for the experiment setup, for the downscaling, we apply it for both SMIP5. First is SMIP5, and then we updated it with SMIP6 just recently. With SMIP5, we use 20 years observation from 1980 to 2005, in which the first 16 years we use for training, remaining 10 years for testing, and the final products use all of 26 years for training. We target the 0.1 degree resolutions output, which is equivalent with 10 kilometer resolution, and do the same with the observation data we have so far. And also target the 21st century climate. With SMIP5, the BCSD were adopted to 31 models with 4 scenarios from RCB 2.6 to 8.5 for precipitation, average, maximum, and minimum temperatures. Then we update the same method, did the same for SMIP6, in which we have more than 10 year longer observation data with a total of 25 GCMs and 7 social share economic pathway, or we simply call it the 7 SSP scenarios, and also target the same variable. And the observation data set we collected at about 500 rain gauge and 157 weather station for the temperature data across the country. And we focus our method validation result for the 7 climatic regions in Vietnam that you can see in the figures. And now I would like to move on with the verification result of the BCSD downscaling. The first you can see in here is the result for the Spatial set. At first, this is the evaluation result for the spatial variability of temperature. Look at the 2 images on the top. You can see we compare the climatology of the similar data BCSD ensemble here with the observation. It's hardly to distinguish the 2 of them, so we can say there is a satisfactory agreement between the BCSD ensemble and the observation data. And we continue with calculating the basis pattern in annual period and the other seasonal climatology in here for both the testing period and the training period. And you see that the basis here are relatively small, ranging only from the minus 0.36 degree and 0.56 degree, which is very small. Seasonal temperature are generally larger than the basis in the annual average, and the higher biases have been found in the static data set than in the training data set. I think this is very understandable. And about the tendency between the 31 climate model, we found in here the strong agreement between the biases tendency in all the models. And next, oh, it's very slow. And next here, the same result for precipitation. As you can see on the 2 figure on the top here, we compare the climatology of the testing period. The BCSD ensemble continue to show a good agreement with observation with the average bias of less than 5% from the testing set. And for the training period, the bias is less than 2.8%, which is very good. And the data result for the training data set is better than the testing period. And next, beside the spatial distribution, we also evaluate the temporal variability of the BCSD ensemble, and also compare it with the simple bilinear interpolation method to see if our effort is worthy when we compare it to the effortless method and traditional, the bilinear interpolation, or we call it the BIP. And here we compare the graded distribution of temporal correlation between the signal cycle in BCSD ensemble with observation and the bilinear interpolation ensemble. And the darker color here indicate the correlation is closer to 1, which indicate the perfect reproducibility. And we can easily see that the BCSD ensemble here is better than the BIP method in every region in Vietnam for both temperature and precipitations. And to quantitatively indicate, to investigate how much better the BCSD compared to the bilinear interpolations, we use another method to calculate the added value of BCSD, which is originally invented by De Luca et al. In 2016. Basically, this method is comparing the error between the 2 methods by calculating the AV metric, we call it added value. And in simply, the higher positive AV is, the better the BCSD simulation result compared to the BIP method. And we calculate the AV here for every grid cells in the simulation result. And here's it AV. And here is the AV result for the temperature data, in which the red color indicate the positive AV regions and the blue regions indicate the negative AV result. But you can see the red color here overwhelmingly account for most of the regions, which indicate the BCSD method much better. It's much better than the ability interpolations. And more interestingly, even when the negative AV value found, it just about -1 to 0, which is very small compared to the huge positive range of AV. That means the difference is very small. With the precipitation result, we also found the same behavior, where the BCSD is overwhelmingly better than BIP. And of that, we can firstly can have some conclusion about the BCSD method. It worked pretty well since the simulation output for SMIP file for the test period is quite comparable to the observations with the low biases. And we continue to downscale with the SMIP6 using the same method. And here I would like to show you the evaluation of the spatial variability for temperature and rainfall. We both compare the climatology, the bias patterns, the training and the testing periods, and drew some and drew the same conclusion. That's the BCSD result for SMIP6. So what is promising, since the biases we found in here are very low. And here is the evaluation result for temporal variability. And look at the dark color of the BC ensemble, where the darker color indicate the correlation at almost every region, every grid cells are roughly equal to 1. The seasonal cycle of the observation will, I think, is perfectly reproduced by the BCSD method. And in here, instead of using the result of average, the result average for 7 climate regions, we extract the randomly, the 7 randomly selected weather stations of these 7 climate region and compare the observation and the BCSD ensemble. For both temperature and precipitation, we see that the BCSD results are still very identical to observations, which is much better than the bilinear interpolation method. And to sum up, we conclude that the BCSD method also works very well with the SMIP6 dataset. And next, we will investigate some future possible change in Vietnam climate. Maybe you can see the similar figure here in Professor Thanh presentation, but I would like to remind some important points in here. Here is the SMIP5 projections for the global in the left image, and for Vietnam in the right image. The solid line here is the mean value, where the shaded region indicate the uncertainty range of the projections. Since temperature in both cases will continuously increase in RSP, the average warming trend in Vietnam are slightly smaller than the global average. The model variability is generally larger in Vietnam. However, what we found in here align quite well with the latest IPCC 6 assessment report. And here is the projections of precipitation for Vietnam in SMIP5. We can see that the trend of precipitation contain more uncertainties compared to temperature. And it will be highest under the high greenhouse gas concentration scenario SP 8.5. And over the entire Vietnam, the BCSD ensemble show a slight increasing precipitation trend, except for some small area in the north and in the south. And in this slide here, I would like to show you the similar result we extract from the SMIP6 projections using the 25 climate models. We can see that SMIP6 and SMIP5 are generally very identical in future trend of both temperature and precipitations, where the change in precipitation will slightly increase in the far future, but not very clear. However, what are the differences between the SMIP5 and SMIP6? If we place them here with SMIP6 on the top figure here, for both global and for Vietnam here, and the SMIP5 result on the bottom, it is very clear that the situation is getting worse than we expected from SMIP5. If you can see, for example, with the highest emission scenario here, you can see that in SMIP6, it's very close to 6 degrees. And for the SMIP5, it's just about over than 5 degrees. So it seems that the warming situation will be much more severe at the end of the 21st century, at least 0.5 degrees hotter than in SMIP5 in both global and in the local conditions. So next, I would like to have some conclusion about the data set we built. The high resolution climate data set we built for Vietnam using SMIP5 and SMIP6 data set, and I think that our validation results show very promising result. The BCSD method show good result in both precipitation, temperature, and precipitation downstream scales. Bias are kept at relatively small value, and the newly built data set show that temperature is projected to increase in all climatic subregions. The warming is more intense in the northern region than in the southern regions, and with the temperature, with the precipitation, we maybe have more rainfall in the far future, but it is not very clear. And my presentation will be end in this slide. Thank you very much for listening.
Thank you very much, Quan, and thank you, Thanh, for this excellent presentation. For those of you who may have found the presentation of the BCSD technique a bit too fast, again, you can take the report chapter 1 and you will have all the explanations again, and also we will of course send the slides after the webinar. So now we will start with our two discussants, and I don't know who will start first. So Hong, is it you?
I guess Professor Tan will be the first one.
Okay, so Professor Tan, the floor is yours.
Yeah, I'm here.
Okay, sorry, I couldn't see you. So.
Thank you very much. May I share my screen?
Yes, please. Also, I see that there are already questions in the audience. Please continue to ask questions even during the discussion time here, and we will answer or put them on the floor after in 30 minutes. So Professor Tan, the floor is yours.
Yeah. Can you see my screen?
Yes, very well.
Okay. Based on two reports, full presentation from Professor Thanh and Dr. Quan on chapter 1, and I have some comment on chapter 1, like below. The first general comment, I think that this report is well organized and easy to follow. That is very good report, and I think the first time in Vietnam I can get a report like that. The second one is in this report, the highlight is new result from the bias correction using BCSD method. This is very good result, and I appreciate it. The third one is, however, many results in this report coincide with those of IMPAN. That means IMPAN report in 2031. The specific comment are below. The first in this report I got from you on page 10. You said that in your statement that it states that the annual temperature increase over whole country with the national and increase of the 0.89 degree between the 1958 to 2018. This is period of the, but this really coincide with the event. And on the page 49, you state that based on daily, that means is this daily use, but this one is used by event, two different time three, and but in the result you mentioned on only this this period, the 1989, 81 to 2010, 18. Maybe the number station is the same. I mean that it seems the data country you use in this report is not consistent. As not consistent. The number, the temperature increase by 0.89 is given by IMHAN is based on this time series data. But as you know that this value, I'm wondering how they did, because I asked some people from IMHAN and they cannot answer exactly my question, because from 1958 to 2018 is very long time series, but very few stations amongst 150 stations have a long time series data like that. Almost they have time series from 1981 to 2018. This is okay, but they use almost here, and they calculate, as I know, they calculate the trend, and they average them. This price of time very long or short, and they combine together, and they got this value. This is incorrect, as I think that. So I think you should mention about the value of this value on the report correctly, exactly where you got, and based on the result you can got, maybe you can get another result. The first thing, and the second one is among the 150 stations, there are some stations like Way station is a temperature decrease trend, not increase like whole country. So did you use a 2-meter temperature of the Way station to calculate nationwide or sub-region trend? If that, please give out it. Because this, as I mentioned, that is the Way station, it has temperature decrease trend. On the page 51 on figure 1.2, at least 2 stations, as I see in the picture, have negative trend of the temperature. One is the Way station, and another I don't know the name of station in the northwest sub-region. Except Way station, did you use do quality control for this station? I'm wondering if you did not do quality control for this station. Maybe the data something like the Way station or something missing. I'm not sure. So please check and please correct it if something happened. Another one is on page 59. You said that in total 19 experiments, something like that. Actually, only for 14 experiments, not 19 experiments. among 14 experiments, you use a whole 14 experiments for temperature, and 5 among them for rainfall. So I think you should correct this sentence. For rainfall, only on the you have 14 space or 14 experiments, but you use only 5 experiments for rainfall. Why is that? Why you don't use 14 space 14 experiments, but you only 5 stations, 5. Yeah. And why project rainfall observed BCSD was not present in this report? It means that I mean that for the future projection, you use only 5 experiments, dynamic conduction experiment for rainfall, but not use rainfall from BCSD projection. On the page 69, figure 1.11, that means annual rainfall change under Sichuan. The projected rainfall is reason from the both VCM and RCM dazzling from the Codex Southeast, so that I can see from IPC report and also from our experiment from Codex Southeast Asia project. This shows that the rainfall in Vietnam will increase in 21st century, especially in RCP 8.5 scenario. And but the horizon shows the rainfall in Vietnam will increase whole country. That means it's like what obtained from IMHED. This means how do you think that? I can show you the picture here. We extract from the Codex Southeast Asia for whole Vietnam, like that is RCP 4.5 and RCP 8.5. Example from only 6 model, but average over whole country almost the temperature, the rainfall decrease, not increase. And for every month, here is winter month, and here is summer month. Almost the dry season. In the southern Vietnam, temperature, the rainfall decrease so much, not increase. So please, I think it should consider this one. Thank you very much.
Thank you very much, Professor Phan Van Tan, for this very detailed analysis of the chapter. Maybe I suggest that we have the discussion of Hong, and then I will let Tran and Quan answer all the comments, and maybe also there will be time for another round of short questions with you. So Hong, the floor is yours.
Oh yes, thanks, Agent. Not sure if everyone hear me well.
Yes, very well.
Okay, so something like my discussion will be slightly different from Professor Tan, because in here I would like to introduce perspective from end user. First and foremost, I would say that this concept is very important, and we don't have any question about the merit of it. It's very important for further research, like we use climate change information and then we put that into our models, for example, to see how the hydrological cycle will change in the future. But in here, I would like to introduce some perspectives from a community. And this is the Young Vietnamese Hydrologist Network. We are people who working in different expertise, and we try to address the water-related issue in Vietnam. And the reason why I showed up this perspective is because people outside hydrology usually sum all of hydrologists into one person. But in fact, we have multiple disciplines. As you can see over here, we have dam impact assessment, we have large sample hydrology, and so on. And so that's the reason why when we talk about this using climate change scenario as a community, we have different perspective about what the data format we want. Because, for example, in our model, we only want a text file, or in other models, we need grid-based data set. And so data format is a problem. And also spatial and temporal resolution. Some people require daily resolutions. Other people require monthly data or annual data. And that's the reason why raw or reprocessed data is another challenge for us to use this data set as well. And also, if you look into this one, our community comes from different countries. And that's the reason why when we are using this one, we need to consider about the technical skills of every single person. We also have different facilities to process and store the data. And also, not all of them are exposed to this new data set. This is relatively new. And it will save a lot of time to bias correct or downscale the data. But the problem here is that not many of these communities hear and know about GMS. But in general, when we talk in our last monthly meeting, we talk about, okay, so how this data set useful and how can we take out the best of it. We have some general agreement like this. The first thing is that the data need to be fair. So it means that it is findable, accessible, interoperable, and reusable. This is not a new concept. It is very famous in the world of scientists globally. And that's the reason why we also raise some questions among ourselves. If I want to use the data set, who should I contact? And the second one is I promote about this webinar event, and people know about that. And they also question, so when will be the next webinar to promote the data set? It's very important. It saves a lot of time. But if we don't have time to attend this meeting, so when will it be the next one? And if no further webinar is organized, so where the record archive, and also GMS, does GMS have a website? Not a fancy one, maybe just a Google site or something like that. But the important part is that they put all the information about the data on that one, because if we want to use the data, we need to clearly understand about the quality of that. For example, the presentation that Dr. Tran Anh Quan presented today, we need to have that information and understand, okay, this one should be used in this region, but not in the other region. And also, the last one is a tricky one. Again, people willing to help us to reprocess the data if we don't have the technical skills or the facility to do that, because we have no idea about whether they have time, they have the interest, or they have any automated tool set for data processing. And those are the questions among us, a community of people who want to use GMS data, but not sure how to do that. I would like to bring a little bit of some applications of this data set on hydrological science. So maybe we can have a floor to discuss further on our collaborations. The first one is that we can investigate climate change on hydrological process across multiple catchments. So this paper we just got accepted on VDS, and it will be in press soon. But the idea is that we collect large enough data set of catchment, because when you're thinking about the impacts of climate change on the hydrologic cycle, we need to consider about the boundary of the impact inside a catchment. But if we just investigate a catchment, for example, in the northern of Vietnam, we have no idea about how the impact go on in the central or the south of Vietnam. And that's the reason why we collected a large enough sample across the country and try to see how the stream flow has changed across the country. Okay, and this one, and when we publish this paper, we're thinking about, maybe it's very interesting to see what is the climate change impact on this in the future. And if you want to do that, we can only consider natural catchments. So it is the catchment that have no major dams, not undergone substantial land use change, and also have a very small fraction of urbanization and stream flow regimes, so no superior change. Because as you can see, some catchment in Vietnam, if you look to the annual flow, sometimes it has a significant drop in 1 year. it is very unlikely that it's because of climate change, maybe because something there are dams built upstream, for example, or people move the gauge around, and that's the reason why. And that's the reason why we investigated this one, and we propose that if in the future people want to investigate climate change impact on hydrological cycles, maybe focus on those catchments. These are the catchments that we identify as there are no major dams. The stream flow regime is quite normal, so that is applicable. So this is one of the applications that I can think of right away. But again, we are quite skeptical about the impact of climate change on the hydrologic cycle in Vietnam, because the general consensus among hydrologists is that maybe climate change is not that important on the hydrologic cycle, because in Vietnam in the last 20 years, there's a lot of dams were built across the country. This is a very, very important database for hydrologists, but it is unfortunate that not all the data are accessible. Some of them are available online, but not on operational rules and so on. This is all the major dams in Vietnam that were built for electrical generations. The question is how those dams impact the hydrological processes across our catchments, and comparing to climate change, which one is more important? And also we have another problem from a hydrological perspective. It is land use change. If you look into this one, it's quite a famous one in Vietnam, right? We used to be covered roughly 70% by forest. It's no longer the case 30 years ago. So how about now? And will these factors contribute to change in the hydrological cycle as well? Okay, so climate change is important. This factor also important. So how can we quantify the relative importance between them? And we propose that maybe we should establish a modeling practice at the national scale. So one simulation of hydrological process run for the whole Vietnamese, for the whole Vietnam, and then we can use different scenarios to detect and attribute the change in the hydrological process to different scenarios. And we identify, okay, we change the scenario of the on-ground activities and no significant change. But if we change the climate input, is the problem. So we can go to the conclusion that's okay. So in Vietnam, climate change are more important relative to the other factors. But at the moment, from my understanding, there's no modeling practice at the national scale. And our group have discussed a lot of times about how we build that, and what is the minor step that we need to do to get to that point. And the final thing that I want to bring to this workshop is that perhaps we need to extending the coverage of our investigations or our data sets. In here, I got this courtesy image from Dr. Đoàn Văn Bình of Vietnamese German University. He also think about this for quite a long time, and he collected a lot of data for the whole Mekong. And our question is, can we collectively produce a new climate change scenarios, not limited inside Vietnam? Because we know that a lot of Vietnamese catchment are international catchment, transboundary catchment, not only the Mekong, but many in the northern Vietnam. We influenced by something happened outside of Vietnam. And so we should not limit our investigation or limit the boundary of our set inside Vietnam. But that's a lot of work. And so how we can do that as a community. And also we need to think about maybe we extend the investigation into temporal scale. In here, I got an image. This slide is from Dr. Nguyễn Tân Thái Hưng from Columbia University. He worked in paleoclimate. So the idea here is that we now have 1,000 years of simulation into the future. But if we put that 1,000 years of simulation in a perspective of 1,000 years in the past, what will we have? And so basically here isotope information, but they can estimate about the drought or the forecast perspective. And thanks for your interest, and thanks for your opportunity to present our ideas in this excellent workshop. Thank you.
Thank you very much, Hong, for this point of view of the hydrologists and this very complementary path for future research, combining a more local anthropogenic change to really disentangle these local effects from the global climate change effects. So I think we have a lot of material to discuss, and now I want to give the floor to Tran and Quan so that they can answer or try to answer some of the points that were raised by Professor Phan Van Tan and Dr. Do Xuan Hong.
Yeah, so thank you very much, Professor Tan and Hong, for I must say that these are very great comment, and I will try to answer some point to give a feedback for some point you raised, maybe not all, and Quan also, please, you can help me to complete the response. So first, for the comments from Professor Tan. So I think your points, you point out the very key issues of the chapter 1 that we had, to face with when we prepare the report, when we prepare the data. The first point about the past trend. So your question related to the different period we use with the in-hand report. So the in-hand report use the data for the period 1958 to 2018, and what we use here is for the period of 1981 to 2018. So when because for the chapter 1, I should say that we have a group of authors working together, a group of scientists working together, including the scientists from IMHAN who prepare also the national report on sea level rise and climate change scenarios. So so that's why there are many common points with the IMHAN report, as you point out, Professor Tan, that we use the same set of observation data. We use the same set of dynamical downscaling experiments because we have to be in line with the national report. That's the first point. So I also fully agree with you about the trend calculation for the past period, and that's why we have renew on those trend estimation for the more recent period. So that's why the results can be a little bit different, from what presented in the national report released last December. Okay, so there's some point you raised about the trend of some localized station, for example, the Hue station and other ones. So for those detailed points, we will incorporate into the report, because we are also going to update the report for the final one. But for example, when we estimate the trend over a region, so we use the time series data of all stations within that region, and then we compute the mean time series before getting the trend. That's why, for example, Hue station, information still be included in the regional estimation. Regarding to the future estimation, you emphasize why for dynamical downscaling we use 14 experiments for temperature and only 5 experiments for models. I have to say that this choice is not our choice. It's the choice of Munre based on the subset of climate experiment they use for the national scenarios. So we because we are working with IMHAN, and we had the request of Department of Climate Change. So we, what we analyze should be in line with what was presented in the national report, and that's why for the BCSD downscaling, we show that there are differences compared to the dynamic downscaling. Okay, it's not the dynamic downscaling is wrong. It's not it's not related to the statistical one is right, or it's not a right and wrong question. It's just a question of a subset selection of the different experiment showing the range of uncertainties of climate projections. Okay, so if we use such this subset, we will have scenarios. If we use another subset, the results can be changed. That's why in our recommendation we mentioned that when we analyze for future climate, we need to take into account the uncertainties of the results we use. Okay, so of course, if we use more experiments, so we can quantify better the uncertainty range. Okay, so thank you very much, Professor Tan, for your great comments. That that they are they are very much on the issues we are facing with. And the discussion of Dr. Hung are also very interesting. I fully agree with you about the concept of the fair data, and I would like to congratulate you for the for the network of the young scientists in hydrology, and I'm sure that I'm seeing many familiar faces and very talented researchers. So I'm sure that you will form a great work group in this field. And your concept about fair data is also what we want to apply in our work package. That's why for the downscaling experiment that the BCSD downscaling that we have. So we follow this fair concept, and you can see here you have question about where we can find the data, or is James had a website. So here is a website from our group showing all the data we use. Okay, the data you can download from for the different variables. We have also a guideline to help you better understand about what we are working on. We are working also on a paper, on an article to describe the data, and later on the data will be also available. So everyone will have a guideline how to use data and how the data was constructed. So that's what we did. And you have a question about whether we have someone who can help not only you but other scientists to extract the data, because the format, because of the data size is extra. So for the moment I say yes, because we are still in the project and we still have resources for doing that. So we will be happy if there's some kind of we have more users. Okay, but because time is always limited and we have only 24 hours per day, so I suggest all scientists, if you want to use data, so you can write to me, to Quân, and we will try to narrow down the question, so we can support you better. But beyond the project timeline, so we will try once to still support you. But for the moment, as I said, we will try to support as much possible, but time is limited, so we also need to harmonize the requests and our capabilities. You raised also a point about whether we can consider some kind of future trend not only in Vietnam but other regions, for example the whole Mekong Basin or Southeast Asia. So it's also something what we expect to do, and we hope to collaborate with you or we can consider that work in the next phase of the project, for example. But we do things that's necessary, and we will be very much happy to work on that. Okay, thank you very much, Professor Tân and Hồng. Quân, if you want to add some more points.
Thank you, Professor Tân and Dr. Hồng, for very interesting comment about. And also thank you, Hồng, for your concerns about the data. And I know that the data acquisition is a big problem. Our climate data usually provide and shared in our specific format, which is not very familiar to many people, especially the researcher don't have experience working with the binary data. And we all know that there is a big gap between our disciplines. So the working package one also found the same problem, even when we have someone who is specific only on the data sharing and working with the data request. When working with the group, we know that data sharing should be focused first. And now we are upgrading our web API service so that anyone can download the data in the daily sequence for 63 provinces. As Dr. Thanh have mentioned earlier, we have a team, Professor Thanh, me, and another researcher at James, who's named Vinh, the IT expert. We are in the beta version development now for the both SMIP5 and SMIP6 web API downloading service. We will provide the daily data sequence for every province in Vietnam. Data will be eligible to download in user-friendly format. It's not in the climatology format, so it's easier to use. And I think the final version of the web API data visualization and downloading will be available for the public soon. It will be soon. It will be available soon in next, I think, in the next months, and we are running the beta version for it. So I hope that you can stay still and wait for the final version of our web API. That's so. If we can do that, even when the project time is over, you can still come to the website and download the data as you need at any time. I hope so.
Yeah.
And we have another question by Dr. Đoàn Văn Bình, who is concerned about the uncertainties in climate change studies, about the different models we use and the different scenarios. So how we as researchers not in the field of hydrology and especially in the government interpret and climate change impact, and what prediction results should the government use to have proactive preparation for the future. So of that, I know that we have a lot of humans and natural forcings that might affect the future climate change. For example, we have the social share economic or SSB scenario with heavily involved with the future development of our economic system. We have the cut-off commitment of the fossil fuel, which also potentially affect the global change. That's why we have many climate scenarios. And for the same reason, we also have so many global climate models, so many models and so scenarios. So we have so many climate models, but in reality, there can be one of them may fit our future. And that's why we need many scenarios and GCM so that the future of our Earth will at least fall in one of the future predictions. So we can prepare for everything. That's why in climate study, we focus not only on the point where every global climate model converge in one point. We also taken care about the uncertainties of the climate protection, which you can see in my previous slides. And what Professor Thanh has mentioned in his presentation in the development of the probabilistic protection, which is very important to indicate the possibility of happen in the futures. And that is what we are doing next in our projects. And there is another question by Job Virtual concerning race separate data option. If we want to separate the data in the urban centers, it's a big issue, big technical issue, because now in climate projections, if we focus on very high detail resolution, for example, for city planning or other urbanization areas, it should be a very big problem when the data will need to be provided in a very high resolution, and it's a big barrier even now for climate study when the computational resources and also the timing problem is still a big issue. And it depends on what you need. Normally for regional research, not specific in the urbanization areas, we can still use the 10-kilometer resolution, which is considered as very high resolution climate data now.
Thank you, Quan. I think you answered also the questions in the chat, so which is good. We have a few more minutes, maybe for reaction from Professor Van Tan and Dr. Do Swan Hong, if you want to react to Tan and Quan's answers, maybe. Or else we can also open the floor for all the participants. So you may want to raise your hands, and then you will be able to talk if you want. So, Professor Van Tan, any reaction, or Hong? No. So then I think, Quan, you pretty much answered all the questions in the chat from Georges Vachot, which was very much related to also Hong's comment, I think. And there was one.
There's a question of Phạm Hải Vũ.
Yes.
Okay. So thanks, Vũ, for the question. I'm not sure if you're still here, and I think that the point here, when we mention about global warming, that means we compare with the pre-industrial period. So 1.5 degrees, for example, is compared with the period of 1850, 1900. And until now, so the increase is already 1.1 degrees. That means we still have 0.4 degrees more to increase from now till the end of century if we still fix the target of 1.5 degrees. So the question is, you mentioned that it has been already quite hot at present. Yeah, that's true, because the global temperature has already increased about 1.1 degree. So we feel really hot, and it will be hotter in the future. And for Vietnam, so according to our estimation, the increase of temperature in Vietnam normally is slightly smaller compared to the global increase, about 0.1, 0.2 degrees. Because we are in the lower latitude, so we don't have the ice albedo feedback issues. So the increased temperature here is smaller than the increase in the high latitude areas. Okay, so I hope my answer is somehow can fit with your question. Thanks, Vu.
And thank you, Tan, for the answer. I mean, we have really few minutes for one or two potential questions from the audience. If you want to raise your hand or just write down the question. So in the meantime, I will just you will allow me to present the next sessions of this webinar series. So next week, March 16th, we will have a webinar on mortality and infectious disease in the face of climate change, chaired by Professor Minh Hong Nguyen from INRAE and Professor Viet Cuong Nguyen from Hanoi National University. The following week, so Wednesday, March 23rd, we'll have the topic of energy demand and supply, the climate impacts on energy demand and supply. Next week, March 30th, we'll have the question of agriculture and rice with Professor Thuy Le Thuan from CESBio and Dr. Thi Hoa Phan from CESBio as well. And the last session of this sequence will be on April 6th on the impact of climate change on labor productivity and household revenues. So all of these next sessions will basically use as an input the climate data and climate scenarios that were presented today, so that it's very strongly related. But of course, they will talk about social and economic impacts mostly. So I hope we will be able to see all of you in the next sessions. I think we can stop this one here. I want to thank again Professor Ngo Duc Thanh, Dr. Tran Anh Quan, and our two discussants of the day, Professor Phan Van Tan and Dr. Do Xuong Hong. I think we had a really exciting discussion, and that will be prolonged in further collective work. And I say you goodbye and see you next week for the second session. Bye-bye.
Thanks, AJ. Bye.
Bye-bye. Thank you, everyone.
Yeah, bye-bye.
Bye-bye, Thầy Tân. Bye-bye, Hồng.
Bye-bye, Tran.